All right, so now we're still talking about key features of linear, quadratic, absolute value functions. Doing a little bit more, but this time we're going to start with average rate of change. Now that's a fancy phrase for something you already know called slope. Average rate of change. You're just measuring how fast the y's are changing based on, and then comparing it to how fast the x's are changing. Okay, so if I were to ask you this question, maybe this will seem a little less complicated. You've been given some coordinates, right? Remember how we would do slope would be the difference in the y values over the difference in the x values. Now, before you start saying, well, Mr. Stailey, isn't it y2 minus y1 over x2 minus x1? Guess what? It doesn't matter as long as you are consistent. Now, this is one of the reasons why I love to write my coordinates vertically. I put my one coordinate on top of the other coordinate, and then I circle the y values. That's the part that goes on top, -3 minus 10. And then the part on the bottom, 4 minus 7. So I have -13 over -3, or 13/3. That's my slope, right? You know how to do that. You've done that before. Not super complicated, but it's extremely important that you understand how to find slope in this particular first topic that we're discussing, because average rate of change is exactly what you just did right there. Now, I know it's going to look a little more complicated when I go over to these notes, but you've got to get it in your mind that it's just slope, because it will look a little bit nastier. So every function, it doesn't matter whether it's a line or an exponential function, or quadratic or absolute value. You guys haven't even talked about exponentials yet, but I know you've seen quadratics. I know you've seen absolute values and linears. So, but no matter what kind it is, they all have, we can find slopes, or what we call average rates of change. Okay. Now, so I'm going to walk through these notes with you. So don't, get all panicky on me because it looks a little weird here. So the interval starts at the value f of a when the x value is a. That would be down here. It ends at f of b when x is b, up here. So this is the start, and this is the end. Okay? So it's just like they're giving me two coordinates on that particular graph. If you want to know the total change in the function values, you would have to subtract the y values. All right? So f of b is the ending one and f of a is the starting one. Well, isn't that the same thing as this over here? And to be honest, like I just said, it doesn't matter whether you start with the starting one and then subtract the ending one, as long as you are consistent. And then, of course, the length of the interval, that's the x values on the bottom. So right here, they show me the difference in the y's. And right here, they show me the difference in the x's. And if you put one over the top of the other, well, dang it, doesn't that look exactly like the slope formula? I know the notation looks weird, but you got to get it in your head, that function notation, f of b, f of a, those are just y values. Nothing more complicated than that. We're just talking about the slope of the line. Then obviously down here at the last part it says the average rate of change is the same as slope, which we've been talking about the whole time, of the line segment between, and then these are the two coordinates, the first point and the second point. Okay? So they're just using the slope formula. Do not let it, don't think in your mind, oh, this is something so strange. No, it's not. It's the same thing you've done for, every slope formula you've ever dealt with back in Algebra 1. Okay, let's go to the next slide. Okay, so for each one of these graphs, we're gonna basically figure out what happens. So this is your plain old y equals -2 graph. We know that's a horizontal line. So when you plug in a -2 for x, guess what you get for y? -2. When you plug in a 0, you get -2. For 3, you get -2. That's because no matter what you plug in, it doesn't matter. You're always getting -2. That's why they call this a constant function. Man, cannot write. What is going on here? Constant function. Okay, right? And they actually showed me the graph. I didn't even realize that that was actually on here. I thought I had to make the graph. So -2, I got -2. 0, I got -2. +3, I got -2. Okay, let's go to the next one. G of -2. So at -2, oh look, I'm at -2. At 0, I'm at -1. At 3, I'm at 0. Oh no, what am I thinking? At 3, I'm up here at 2.5. No, 2.5. I'm using the 2 on the x-axis. That's ridiculous. That's only 0.5. Gee whiz, Mr. Stailey. Okay, so -2 here puts me at 4 there. 0 puts me at 0. And 3 puts me all the way up here at 9. Okay? So we've got coordinates, right? So if you're dealing with the interval from -2 to 0, which is what they're asking me, so -2, -2 to 0, -2. Remember, this is just a slope formula. That's all they're asking me to do. So don't make it any more complicated than that. So now it's just difference in the y values, over difference in the x values, which that would be 0 over -2, and 0 divided by anything is just plain old 0. And I hope that you know slopes of horizontal lines are 0. Here's how my math teacher taught me how to know that. Because if you look at the top line of a capital Z, wow, man, I'm learning here, folks. Right on the screen. My stylus, my computer screen doesn't like it. So the top line being horizontal is like the top part of a Z for 0. Well, what happens from 0 to 3? Okay, so that's 0, -2 to 3, -2. So now I'm going to do a very similar thing to what I did before. Difference in the y values over difference in the x values, 0 over -3, and that still gives me 0. And lastly, they want from -2 to +3. And so if we're going from -2, -2 to +3, -2, and then we're going to go through the process. Difference in the y values over difference in the x values. So 0 over -5, still 0. So every single time you did that, you came up with a 0 for the slope. Now, I did not leave enough room to do this again. Okay, pause if you need to pause. I'm going to erase some of this and give myself some room to redo this for the middle ones. And I'll have to zoom in because I'm obviously writing too big. Okay, so set up my my coordinates ahead of time here so I could do this a little bit faster. -2 minus -1 over -2 minus 0, and that would be -1 over -2, which is 1/2. And on the next one, oops, -1 minus 0.5 over 0 minus 3 equals -1.5 over -3. Oh, look at that, 1/2 again. So -2 minus 0.5 over -2 minus 3. So -2.5 over -5. Oh my goodness, look at that, 1/2 again. All right, now these two situations that always came up, the first one always came out being 0 when we did this before. We got a 0 for this one, and a 0 for that one, and a 0 for that one, and then these all ended up being a half. Those are both telling me we're dealing with linear functions. That is not going to be the same case when we get over here to this one. Let me pause so I can get my coordinates written down. So if I do this, I'd have 4. Come on, 4 minus 0. Right, dang it. -2 minus 0. So 4 over -2, which is -2. Here we have 0 minus 9 over 0 minus 3, which is -9 over -3, which is +3. Ding, ding, ding. See, these are not going to be equal to each other. And then now here we got 4 minus 9 over -2 minus 3, and we get -5 over -5, which is +1. So right there, we see that these are not the same. So that's kind of important. So that means not linear. Now we'd have to get more specific if we were, looking for a section of a graph which was linear, but it's pretty clear that this picture is not linear. We are not dealing with any kind of line there. The rates of change are drastically different. That's the point. Let's go to the next slide. Okay, so key features here, domain range intervals of increasing, decreasing, x and y intercepts for each graph. So some of the things we've been working on each day. So we're starting off with y equals x. Just a basic, you could write that y equals 1x plus 0 if you wanted to. Same exact thing. Slope of 1 goes through the origin. Domain, remember if you smash it all onto the x and y axis, the x-axis first, you'd go from -infinity to +infinity. If you smashed it all on the y-axis, the same exact thing would happen to the y-axis. Increasing, right? You're moving from left to right through the graph, and it is all increasing, -infinity to +infinity. Okay, and none of the graph is decreasing, right? Because remember, you're moving left to right through the graph, kind of like on a roller coaster. X-intercept, to be technically correct, it is a coordinate. The x-intercept is 0, 0. Now, sometimes we focus only on the x value because we know the y value is 0. Every x-intercept in the universe has a y value of 0. Likewise, the y-intercept in this case is exactly the same coordinate, 0, 0 again. Sometimes we only emphasize, so on the x-intercept, sometimes we only emphasize the x, and sometimes on the y-intercept, we only emphasize the y because we know the other one is automatically 0. Okay, next graph over, y equals negative x. So domain, smash the whole thing on the x-axis, negative infinity to positive infinity. Smash it on the y, same exact thing is happening, just like we've seen before in class. Increasing, none. None of that graph is increasing, right? Because as you move from left to right through the graph, you'd be going down, 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 down the whole time, negative infinity to positive infinity. X-intercept, still 0, 0. Y-intercept, still 0, 0, because they both cross right through the origin. Okay, so what happens with quadratic? Smash it all onto the x-axis, and come on. Negative infinity to infinity. But if I smash it all on the y-axis this time, it starts out at 0 and goes up, 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 up. Okay? Increasing. Well, remember, let's go from left to right. So the first part over here, this is actually a decreasing section. So from negative infinity to 0 is decreasing. But as soon as we hit the other side, from 0 to infinity, it is back to increasing. Don't put brackets on any of those because you cannot include 0 in either one of those, and you can never touch infinity or negative infinity. X-intercept, still 0, 0. Y-intercept, still 0, 0. Crossing right at the origin. Okay, so what happens if it's upside down? We got negative infinity to infinity. Range this time, remember, we always go smallest on the left, largest on the right. You are going to lose credit if you put 0 to negative infinity. Always smallest on the left, largest on the right. Okay, please, 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 please write your intervals that way. Increasing. Well, on this side of the graph is increasing, so that would be from negative infinity to 0. And over here, this side's decreasing from 0 to infinity. X-intercept, still 0, 0. Y-intercept, still 0, 0. When we start shifting these graphs around, those x-intercepts and y-intercepts are going to change. So when we start moving stuff around, it's going to get different. Okay, I'm going to go to the next slide. Okay, if you push that whole graph down on the x-axis, negative infinity to infinity. Range, push it all on the y-axis, starts out at 0 and goes up, up, up. See, this side of the graph as you move from left to right is decreasing. So that would be from negative infinity to 0. But then once we hit 0, it switches to increasing, going back up, up, up. Once again, x-intercept, man, every one of these x and y intercepts are always the same, at least so far. See what else we end up with here. Okay, so the reflected version of that, the upside down version of that absolute value function. Smash it all on the x-axis, pretty standard, negative infinity to infinity. Smash it all onto the y-axis, and we would be going from negative infinity up to 0. Bracket. Did I do the bracket on the last one? I better check just to make sure I didn't screw that up. Nope, wrong slide. Whoa. You remember how I taught you kids that you got to look for mistakes? You got to look for mistakes. Right there was a mistake. That's supposed to be a bracket because it includes 0. That thing comes up and it touches 0. And since it touches 0, it has to be included. Good thing I remembered that. Okay, let's go back to the other one now that I've fixed my mistake. Okay. This section over here from negative infinity to 0 is increasing, and then it switches and goes back to decreasing. X-intercept still 0, 0. Still 0, 0 for my y-intercept because everything's crossing at the origin. All right, let's see what we got here. Constant function. All right. Okay, so if I slammed all that down on the x-axis, it would be negative infinity to infinity. But the range is different here. The only number in the universe in the range is 3. It's not an interval, folks. It's just the number 3. Now, how much of that graph are you going up, 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 up as you go from left to right? None of it. How much of it are you going down as you go from left to right? None of it. What's your x-intercept? Where does that thing cross the x-axis? No x-intercept. Or you could write none. I don't care if you write none, no, not applicable. You know, undefined. I mean, all those things mean the same thing. How about that y-intercept? Where does it cross the y-axis? So we might say 3 just because we know that the x value is automatically 0, or we could write the coordinate 0, 3. But sometimes we'll just say 3 because we know that x value is automatically 0. Okay, so that's enough notes for this lesson, and hopefully you'll have some questions in class tomorrow.